Okay. Hello. Today we will start with the number three handout for digital fundamental. Latch. Okay. The latch is type of the temporary store device that has to stable state that we call bistable and now it normally placed in a category separate from that of FlipFlops. Latch are similar to the FlipFlop because they are bistable device that can reside in either of two steps using a feedback arrangement and in which the outputs are connected back to the opposite input. The main difference between latch and flip-flop is the method using for their state. Okay. Now we're talking about SR reset, set and reset latch. A latch is a type of byte table, logic device, or multivibrator, and actually high input SR. Latch is formed with two cross-coupled NOR gate. So basically, they're given to you two latches, one using the NOR gate and another one using the NAND gate. And this is what we call an active high input SR. So that's why you can see R input S input different from not F input, not R input. Okay? So that's why you see the symbol SR. And for the NAND input, you get a bubble here. Okay? That will be active low. And the other one, active high. Okay? However, when you see this symbol, and you have to understand inside here, that means choose order. And this is a symbol for the SR active load. Inside that symbol will be this circle. Okay? And this is given to the truth table for the man plot. And for another one, the norm. Okay? If you get an input S and R, you want to know the output Q. Okay? Look into the truth table. F0 R0. That means you get a 0 here, 0 here. Output, they say, not allowed. What that means? Not allowed. That means output Q and output not Q. They have to be different. Okay? They cannot be the same. For example, Q equals 1. Not Q have to be 0. Or not Q1. Q have to be 0. That means not allowed. Okay? If S equals 0, R equals 1, then Q equal 1 and not Q equal 0. And X equal 1 are 0. Output Q 0 and not Q equal 1. However, if you get a 1 here, the output they say no change. No change. What that means? That means if it was 1, 0, then you apply 1 and 1. Output cannot be changed. Still 1 and 0. Okay? That means no change. No change means you changing input, however, output not changing. And this will be applied same thing for this NOR gate FlipFlops. Okay? On the left. F0, R0, output no change. And 0, 1, you get 0, 1, 1, 0, you get 1, 0. And if you get a 1 input, another 1 output, they say no change. That means the output not changing at all. So, in order to calculate the C, what output equals, you need to know how to read the truth table after you get an input at R. And you want output, you're looking into the truth table. Okay? Depending NAND gate or the NOR gate left. Okay? Okay, and this one, they given you the example. They given you not F, not R. You understand? Inside, this one will be the NAND FlipFlop. Okay? NAND FlipFlop. So, they assume that Q initially 0. That will be only telling you one thing. At the beginning, Q equal 0. Okay? And then, if you want to roll, then you have to look in next at equal 0. R equal 1. What key? You looking into the truth table. At equal 0. R equal 1. Q equal 1. So that means Q will be equal 1. And so on. Okay? I think we will be doing this in the class. And the same thing. Next one. They given you the NOR gate. And the truth table. Okay? You will be drawing the output when they given you the input. Okay? For example, at the beginning, you get a 1 here, 0 here. R equal to 1. Okay? F equal 0. Q equal 0. Okay? So we will be doing it in the class. Okay? The next, the gate at R left. Basically, this is the gate at R left. That means this circuitry inside the symbol. You get input S, you get input R, and you get an enable. Only thing, the difference will be, okay, if enable equal here input 10. Output doesn't change. Okay, so if if enable equal to 1, then output will be 10. Okay, output will be 10. And this is also the example for the get at a lab. If you want to know the output, then you need to know how to understand what happened in the input. For example, if you get F 0 R 0, then output they say no check. Okay, now you can see on this one, I got a Q. Initially equal 0. Why? The thing that they say initially reset. Okay, that means output Q will be reset at the beginning. That means equal 0. Okay, then we can go depend on FR. Okay, so basically when the enable equal to 1, then the output will be 10. So you have to know what F equals, what R equals. Okay, I can see right here, F equal 1, R equal 0, F equal 1, R equal 0, Q equal 1. So Q will be equal 1. Okay, and go to the next one. You see that? Enable equal 0. We already said enable equal 0. You can send input but the output doesn't change. So that's right. And not sending it, they should be 1 until this goes to 1. If you want to know, then you have to know input 0, input 1, what output, and we can go. Okay? What I am saying is, we will be doing it in the class. Now, the next one, we're talking about the get locked. The lock. Okay? You can get enable and you get input D. Okay, we don't care about this circuit. However, this is a simple, you must know, enable and the D. Okay? That's only telling you one thing. If enable as a logic 1, Q will be equal to D. Okay? Let's see what I can say. Okay? Q equal D. If enable equal 1. Okay? If enable equal 0, Q no change. Okay? So for Q equal to D, enable must be 1. Otherwise, you can change D. If enable equal 0, Q cannot be changed. Okay? And this will be example. We're working on the left. If you can get through it correctly, that means you understand. Okay? And also, next one, same thing, we'll be doing in the class. And now, we're talking about a flip-flop. Okay? Flip-flop. Okay? Synchronized bistable device, also known as bistable multi-vibration. In this case, the term synchronous means that the output can step only at a specified point, leading or trailing F on the trigger input clock, okay, which is designed as a control input. Okay, clock that is then in the output occur in synchronization with the clock. Flip-flop at trigger or at density where various get that level density. We already talking about the last input changing, okay, output changing. However, flip-flop are different. Flip-flop will be controlled by a trigger, okay, not level trigger. That means the clock signal either going up or going down. Okay, we'll make it work. Okay, anyway, you can get two flip-flop. One will be the D, and another one will be a JK flip-flop. Now, they given you one D and one JK, D flip-flop. You get one input D, and you get a clock. And this clock going 0 to 1. Okay? Let me tell you, clock go up. Okay? You see on the truth table, D0. If you get a clock going 0 to 1, then Q equals 0. D equals to 1. Clock going up, Q equals to 1. Very simple. Okay? So the clock equals 1 or the clock equals 0. You can leave. You cannot be changed. So just see, they're working on basically clock going. Either go to 0 or go to 1. Another one they say, good luck. Clock now will be going down. Okay, if you get a clock going 1, 0, that means clock going from 1 to 0. You get the K, you want to get Q, looking into the truth table. Okay, you already know. No chance. Here, J0, K0. You get a clock going high to low. Output they say no chance. That means it was 1, they still 1. It was 0, they still 0. And 0, 1, you get a clock going down. Output to 0, not to 1. And the next 1, 0, you get to 1, 0. Now I want to explain to you. When you get J1, K1, you get a clock. Output they say toggle. What that means? Toggle means if it was 1, now they 0. If it was 0, now they be 1. Okay, so that's the IC for 74D flip-flop. Okay, power will be 14. Ground will be pin 7. Look inside, you get 2D in one packet. See that? 2D. And the pin 1, 2, 3, 4, they telling you they will be cloud or they will be D or whatever. Okay. And another one, this is JK flip-flop 74, 76. Okay. 14, power, pin number 5. That's special. That will be 5 volts. Ground will be pin number 30. Okay. That will be ground. And also inside, they get 2 JK flip-flop. One here and one here. So in a one packet, they get 2 JK and the pin telling you is it input J or K or clock or whatever. Okay. And now what's in here? Oh, this one, it doesn't matter. Okay, to you. Only thing is, what they try to do, they get the clock wider and they go through this circuitry. Now you get a new clock will be narrow, smaller. Okay, that's it. And then in here you get hello. Okay, so when the D flip-flop, you connect not Q back to the D. What happened? That's just a divider. Okay, divided by 2. For example, you get a clock here. $10 kilohertz. If you make a connect this way, output coming out 5 kilohertz. That's what divided by 2. And that happened the same thing for JK. If J and K tie together and connect into logic 1. Then they divide by 2. Same thing. Okay, so now you see they connect not Q back to D for both D flip-flop. So that's only telling you if you get 10K kilohertz coming in, coming out here will be 5 kilohertz. And the output that goes to the next flip-flop D, the same connection. And the output will be divided by 2 again. That means at the QB here will be 2.5 kilohertz. That will happen the same thing for the JK flip-flop. Okay? Not a big deal. And now they've given you the flip-flop. They give to you the clock and the D. And they get initially, okay, output will be reset. So, first thing, we need to identify the clock transition. Here, D flip-flop go up. What that mean? That means output still only changing at the transition 0 to 1. Without transition, output cannot. And at the beginning, they already given to you. Still initially reset to 0. Okay? So when the clock, okay, goes 0 to 1, what D? D equal 0. Still equal 0. And they will be 0 up until next transition. Okay? And so far, we'll see next in the class. This is the same thing for JK. Okay? We will be exercised in the class. Okay? This is just an instruction telling you. Okay? Preset and clear. Input must both be keep high. Okay? The preset and clear input must be both high for synchronous operation. If you want the clock working, then preset and clear must be high. In normal, preset and clear would not be low at the same time. Okay? That means they get a two input special. One will be preset, one will be clear. If preset 0, Q must be what? Doesn't matter. you get a clock transition or not, doesn't matter. You know why? The thing in a computer, they really controlled by the master clock, everything by the clock. However, sometimes we want to set the output of the flip-flop to logical 1, not depend on the clock. That's why preset equal 0 still must be 1. And the same, clear, same function like preset, but the clear equal 0. Then output flip-flop must be 0. Doesn't matter. You get the clock transition, okay? And they make sure preset and clear must be at the logic 1 for the clock keep cooking. Okay? And this will be example related for the set and reset. Okay? We will be doing it in the class. Same thing here. Okay? So I will be trying to give you a handout and we will be go through that lecture quickly. And I want you to complete all of the drawing timing in this handout. Okay? Any questions? If not, I stop here. Okay? Bye.